All right, fantastic. So what we're going to do now is work through a somewhat simplified version of a model of the economy developed by Stephen Coate and Glenn Lowry in a paper called Will Affirmative Action Policies Eliminate Negative Stereotypes? So the basic idea of this model is it's proposing a solution to this question of why the bigot tax doesn't drive prejudiced and discriminatory firms out of the market over the very long run in a market economy. Right? In other words, this is a model to try to understand why discrimination might persist over the long run, right, even given competitive market forces. And in fact, as we're going to see, in this model, competitive market forces, instead of pushing prejudiced firms out of the market, they actually keep prejudiced firms in the market. They push out any firms that try to do anything to address root causes of prejudice. So how does this model work? The basic idea here is that we're going to think about two groups of people at the same time. We're going to think about the decisions that employers make, about who to make job offers to, and we're going to think about the decisions that employees make, workers make, about how much to invest in improving their skills, right, and increasing their value in the marketplace. So fundamentally, this is going to be a statistical discrimination model. And the reason for this is that when employers decide who to hire, they do so with some information about how skilled employees are, but with imperfect information, right? So that they have to, at some level, guess about who is and is not going to be qualified for the high-paying jobs. Now, the way that prejudice plays a role in this is that employers might base their guesses in part on the racial characteristics of their employees, right? In other words, they might have different beliefs about the qualification of black candidates on average relative to the qualification of white candidates on average. Now, as we just saw, right, if employers made assumptions about candidates based on their race that were incorrect, we would expect them to change their beliefs over time. That's where the employee side of the market comes from. Coate and Lowry are going to say that white and black employees, white and black workers, are fundamentally identical to each other, right? They don't have any differences at all in their characteristics. They're the same people. However, both white and black workers are going to make decisions about what kind of sacrifices to make in order to become qualified for high-paying jobs, in part based on their beliefs about how likely it is that they'll be offered a high-paying job if they do the work to get qualified. As a consequence of this, right, what we're going to see is that if employers' prejudice is high enough, right, if employers are, as a group, are prejudiced enough to make it unlikely that even qualified black candidates get high-paying jobs, the consequence is going to be that black workers are not going to invest in their qualifications, right? They're not going to make massive sacrifices in order to build qualifications, build a resume that's not going to get them a high-paying job. And as a consequence of this, employers' beliefs about the different qualifications of black and white workers can be maintained because those differences were produced by the prejudice itself. Okay, so that's just a really big picture rundown, right? We're going to show this mathematically in a super simple version of the economy, where we just have two types of jobs. Laborer jobs, which don't require any qualification, and engineer jobs that do require qualification. I'm going to start us off by describing the way that this economy works without including race and without including prejudice in the model at all, right? Just to start with the basic dynamics. Once we have that, we're going to see how the story changes once we introduce racial prejudice into this model. So to put some made-up numbers on this, let's imagine that laborers get paid a wage of $40,000 a year. Engineers get paid $100,000 a year. And let's imagine that if a worker is skilled, right, if the worker is qualified, they'll produce $40,000 a year as a laborer or $200,000 a year as an engineer. Right? On the other hand, if a worker is unskilled, right, they didn't invest in their qualifications, they'll still produce $40,000 a year as a laborer, but they'll produce nothing at all as an engineer. Right? So the basic idea here is we're saying that, you know, being a laborer doesn't require any skill, right? There's nothing to find out about a worker. Employers don't care if a laborer is skilled or not. You produce $40,000, you get paid $40,000. Being an engineer is different. If you're skilled, you're going to produce more than your employer pays you. If you're not skilled, you're going to produce less than your employer pays you, right? You're not going to produce anything at all. So as a consequence of this, the first thing to think about is what this implies about an employer's hiring decision, right? We know that employers are going to hire whoever as a laborer, but we might want to think about how likely do employers how likely does it have to be, from the perspective of an employer, that a worker is skilled before the employer is going to be willing to hire them as an engineer? This question makes sense? So we can do this using this exact same idea of expected value that we used before when we were talking about statistical discrimination. Right? Let's say that we're going to call P probability that a worker is skilled. Right? Then we can say that the expected profit, right, from an employer of hiring a particular worker as an engineer so from hiring an engineer is going to be, right, expectation of the profit as a function of P is going to be P, right, the probability the worker is skilled, times the profit the firm makes if they're skilled, I mean 200,000 minus 100,000, right, plus 1 minus P times the profit they're going to make if the worker isn't skilled, right, which is going to be 0 minus 100,000. This makes sense? Great. So this means our expected profit is going to be, right, 100,000 times P plus 1 minus P times negative 100,000. Good? Right, basic idea here, you make $100,000 with probability P by hiring a skilled person. You lose $100,000 the rest of the time, right, with probability 1 minus P by hiring an unskilled person. So when's it going to be worth it to hire someone? Well, you're going to want to hire someone as long as the expected profit from hiring them is greater than or equal to 0. Right? As long as you expect to make more money than you lose. Make sense? So now, right, what that's going to let us do is find out the maximum probability, or I'm sorry, the minimum probability that someone's hired, that someone's skilled, before a firm's going to hire, right? So you just solve this in terms of P. Say 100,000 P minus 100,000 plus 100,000 P equals 0. So P, or I'm sorry, has to be greater than or equal to 0. So P has to be greater than or equal to 1/2. Right, 100,000 over 100,000 times 2. What this is telling us is essentially because of the fact that employers lose the same amount of money by hiring an unskilled person as they make by hiring a skilled person, they're going to hire any employee where they think the likelihood of you being skilled is greater than 50-50. Okay, so far so good? Wonderful. So that tells us that if a firm thinks that someone's more likely than not to be skilled, they're going to hire them as an engineer, right? Otherwise they're not, they're going to hire them as a laborer. So how do firms decide whether they think a worker is skilled? Let's imagine that they give them a test. And the way that this test works, right, this qualification test, is that if you're skilled, which I'm going to call S equal to 1, you always pass the test. And if you pass the test, I'm going to say that Z equals 1. On the other hand, if you're not skilled, which I'll call S equals 0, you pass 1/3 of the time. Make sense? So they're basically giving employees a test that gives them some information about whether or not someone's skilled, but isn't enough by itself to conclusively say whether a worker is skilled or not. So this is where we're going to leave the employers. The important point here is the employers are going to have to decide, do they think that passing this test is enough evidence that makes it worthwhile for them to hire a worker? Make sense? Great. So let's stop here with the employers, shift over to thinking about what the workers are going to do. So in this model, we're going to imagine that workers are just trying to get whatever set of qualifications and jobs increases their income the most, right? Gives them the highest take-home pay. And as a result, because engineers get paid so much more than laborers, they're always going to want to take an engineering job if it's offered to them. As a result, the only decision in front of them is whether or not they want to get skilled. So we're going to imagine that every single person in this economy, right, all workers start out unskilled, but if they invest $20,000 in a training class, they can become skilled, right? So all workers start out unskilled, right? Costs $20,000 to become skilled. This makes sense? So what workers are trying to decide is whether or not it's worth it to become skilled. Now, as we said before, right, when we thought about this from the firm's perspective, the firms could have two potential hiring rules, right? The first hiring rule would be to say, let's hire everybody who passes the test, right? The second hiring rule is, let's not hire anybody regardless. So let's imagine first that we've got hiring rule 1. Just hire anyone who passes test. In this case, let's think about what a worker is going to earn if they decide to become skilled and how much they're going to earn if they decide not to become skilled. So if a worker becomes skilled, there's two possibilities, right? Either they pass the test and get qualified and then get hired as an engineer, or they don't pass the test, they aren't deemed qualified, and they don't get hired as an engineer, right? So their expected earnings are going to be the likelihood of passing test, right, given that they are skilled, right? This is just terminology to say the likelihood that they pass the test if they're skilled, right, times what they earn if they're skilled. It would be $100,000, right, plus the probability that they don't pass the test if they're skilled, times what they earn if they don't pass the test, which is $40,000, right? This is their expected earnings, and then minus $20,000, right? Because they're going to have to pay for the test in order to become skilled, right? They're going to have to pay for their training. Sorry. So in this case, the probability that you pass the test if you're skilled is 100%, right? Probability that you don't pass is 0%. And then you pay the $20,000 in training cost. So this means that their earnings, if they decide to get skilled, are going to be $80,000, right? Their expected earnings. This makes sense? How about if they decide not to get skilled? What if they decide not to pay the $20,000? If they decide not to get skilled, we'll figure out their expected earnings exactly the same way, right? We'll say if S equals 0, it's going to be the probability that Z equals 1, given that S equals 0, right, times 100,000, plus the probability that Z equals 0, given that S equals 0, times 40,000, and then minus 0, right, because they don't have to pay any training costs. So this is going to be 1/3 times 100,000, plus 2/3 times 40,000, which is going to be $60,000, right? So if they decide to get skilled, they know that they're going to make $80,000, right? Because they're definitely going to pass the test, definitely going to get a $100,000 job, definitely going to have to pay $20,000. So they'll make 80,000. If they decide not to get skilled, they've got a 1 in 3 chance of getting the high-paying job by luck, 2 in 3 chance of having to be a laborer. They don't have to pay the training costs. In this case, because 80,000 is bigger than 60,000, their best case scenario, right, their best decision is going to be to choose to take the test, right? And choose to get skilled so that they've got a sure chance of passing the test. This make sense? If you know that you're going to get hired as an engineer if you pass the test, the best thing you can do is to become qualified to be an engineer, right? How about the second hiring rule? How about if we had a rule where we don't hire anyone? Well, in that case, if you decided to become qualified as an engineer, you would earn $40,000, right? You'd have to work as a laborer. You'd lose $20,000. So you're going to lose money, right? You're going to end up with an income of $20,000, right? So if S equals 1, right, you're going to earn 40,000. You're going to lose 20,000 for the cost of becoming qualified. You're going to earn 20,000. And if S equals 0, you're going to get 40,000. You're not going to pay anything. You're going to end up with 40,000. So your best move is going to be to not get qualified, right? If they're going to hire people who pass the test, it's going to be worth it for everyone to get qualified. If they're not going to hire anyone, it's not going to be worth it to get qualified. Make sense? Great. So that's all we need to know about workers. This tells us once we know what rule the firm's going to put in place, we're going to know how workers are going to respond to that rule. Great. So what we just figured out is that a worker's decision about whether or not to spend the $20,000 to become qualified depends on whether getting qualified or passing the test is going to guarantee them a job as an engineer, right? If firms hire people who pass the test as engineers, workers are going to get qualified. If firms don't hire people who pass the test as engineers, workers are not going to get qualified, right? So now we need to know, is it going to make sense for firms to hire workers who pass the test as engineers? And what we're going to remember here is that the firm's ultimate goal is to hire anyone as an engineer whose likelihood of being skilled, right, of actually being qualified for the job, is at least 1/2. So what we need to know is, if we know that someone passed the test, how likely is it that they're skilled, right? Which I'm going to denote as the probability that they're skilled, given that they passed the test. Right? Make sense? Great. So in general, if I see that somebody passed the test, and I want to know whether they're skilled, we can think about the likelihood that they're skilled as being the number of skilled test passers divided by the number of test passers. This makes sense? Anytime we want to know, right, the likelihood that something's true of someone, right? If I want to know the likelihood that someone can whistle, that's going to be, I'm basically going to say, what's the number of whistlers over all of the people in the world, right? I want to know whether you are an athlete, given that you go to Oxy. I'm going to say how many people go to Oxy and are athletes, how many people go to, divided by how many people go to Oxy. Make sense? Great. So what this is going to be, so from here what we can say is that there's basically 2 ways that you can pass this test. The first way you can pass this test is by being skilled, right? We know that every skilled person passes the test. But the other way that you can pass the test is just by dumb luck, right? By not getting skilled, but being one of the 33% of unskilled test takers who end up passing, right? So test passers is going to be skilled people plus unskilled lucky people, right? And the skilled test passers are going to be all the skilled people. This makes sense? Great. Another way we can think about this is using a tool called Bayes' theorem, which I'm happy to talk to you more about. It's a really, really interesting tool across the board. But it's going to be able to tell us essentially what percentage of the overall group of people fits into each of these two categories, right? Skilled people and unskilled lucky people. What we're going to say is that the likelihood that someone is skilled is going to be the probability that someone passes the test if they're skilled times the likelihood that someone is skilled. What's the idea here? The idea here is if 80% of people are skilled and 40% of people pass the test who are skilled, or 50% of people pass the test who are skilled, right, then I would guess that the likelihood that any particular person is a skilled test passer is 50% of 80%, right? This is what we're saying. Similarly here, the likelihood that a particular person is skilled is going to be, given that they pass the test, right, is going to be, or I'm sorry, the likelihood that a given person is a skilled test passer is going to be the probability that someone passes the test if they're skilled times the probability that they're skilled. Same thing. How about the likelihood that a given person is an unskilled lucky person? That's going to be the probability that you pass the test, given that you're not skilled, times the probability that you're not skilled, which I'm going to call 1 minus the probability that you're skilled. Right? Since there's only two possibilities. Does this make sense? So this here is just a restatement of this. Right? What we're doing is we're saying what fraction of the total workforce are skilled test passers divided by the fraction of the total workforce that are test passers. Does this make sense? So because 100% of skilled people pass the test, right, and 1/3 of unskilled people pass the test, this is going to be probability that you're skilled over the probability that you're skilled plus 1/3 times 1 minus the probability that you're skilled. Make sense? So what's this telling us? This is telling us that if we observe your test score and know that it's possible that you either pass the test by skill or pass the test by luck, how seriously we take your test score, right? How likely we are to believe that you're actually skilled is going to depend on how likely we thought it was that you were skilled before you ever took the test, right? This PS equals 1 is essentially our belief about what percentage of the overall workforce is skilled. This makes sense? The way to think about this is, let's say that we've got two different labor pools, right? One labor pool that we're testing to see if they're skilled as an engineer is going to be, recent graduates of MIT, right? Recent graduates of MIT's engineering school. We think that almost all of them are skilled. Another is going to be a random selection of people who happen to be shopping at Rite Aid right now, right? So if I thought that 90% of MIT graduates were skilled, right? So if PS equals 1 is 90%, right? How likely would it be that I thought that an MIT graduate who passed this test was going to be a skilled engineer? Well, I would say that PS equals 1, given that Z equals 1, would be 0.9 over 0.9 plus 1/3 times 0.1. Right? So this is going to be 0.9 over 0.933, which is going to be 0.97. Right? In other words, if I was already pretty sure that someone was skilled before they ever took the test, seeing that they passed the test would make me even more sure. And if I'm this firm, right, who's going to hire anyone whose likelihood of being skilled is above 50%, I'm definitely going to hire any MIT grad who passes the test. On the other hand, let's imagine that I was giving people an engineering test, right, who randomly walked out of Rite Aid in the middle of the afternoon, right? And I thought that the Rite Aid shoppers have a probability of being skilled that's a lot lower than 90%, right? Let's say I think only 20% at most of Rite Aid shoppers happen to be qualified to be engineers, right? In this case, I'm going to say that if I see that somebody passed the test, how likely is it that I think they're skilled? Well, it's going to be 0.2 over 0.2 plus 1/3 times 0.8, which is going to be 0.2 over 0.2 plus 0.222 is going to be 0.47. In other words, if I thought it was pretty unlikely that you were skilled, just given that you were a random person out of Rite Aid, right? I don't think you're very likely to be a skilled engineer. And then I see that you passed this test, right, that has a reasonable chance of getting passed by chance. I'm going to think it's more likely that you're skilled than I did before I saw that you passed the test, but I'm still not going to think it's all that likely that you're skilled, right? Because there's so many more people who I think are unskilled in this population than that I think are skilled. I still think it's more likely than not that you're one of the unskilled people who passed by chance, rather than that you're one of the skilled people who passed by skill, right? Whereas out of the MIT grad, since I thought there were very few people who are unskilled to begin with, I think it's pretty likely that you're one of the unskilled people who passed by chance. This make sense? Great. So in this case, right, I wouldn't decide to hire a random Rite Aid shopper who I saw was able to pass this test, because I think that the likelihood that they're skilled is less than 50%. This means is that a firm's decision about whether to hire a worker who passes the test or not is going to depend on how likely the firm thinks it is that a worker was qualified before they see that worker's test score. Now, in a normal statistical discrimination model, right, if we're thinking about whether or not you have a rich friend, maybe this wouldn't matter all that much, because we would think that over time, firms who are right about whether a worker was qualified would make money. Firms that were consistently wrong would lose money. In this case, though, let's think about what workers are going to decide to do in each of these two situations. So in this situation, the firm hires test passers, right? The firm hires test passers. Then, as we saw before, a worker who studies for the test, right, who pays the $20,000, is going to earn $80,000 on average. A worker who doesn't study for the test is only going to earn $60,000 on average. So all workers will become qualified. If all workers become qualified, then firms who used to think that a test passer had a 97% chance of passing the test are actually going to become even more optimistic, right? They're going to say, wow, we haven't had a dud in years. Everybody seems to be good at engineering, right? They're going to continue to hire everyone who passes the test. On the other hand, over here, when the firms were skeptical of workers' abilities, right, thought workers were unlikely to actually be qualified, the firm won't hire. Right? They don't hire you even if you do pass the test. And what this means is that a worker who goes to the effort of studying for the test, right, of becoming qualified, is going to end up throwing $20,000 down the toilet, right? They gain nothing from it. So workers refuse to get qualified, workers don't become qualified. Right? And instead of firms learning over time that workers are better than they thought, they're going to learn over time that workers are a little worse than they thought. Right? They're going to see that anytime someone does try to hire someone who passed the test, that person always passed the test by chance. Right? They're going to see this because of the fact that their hiring policies result in the workers not getting any benefit from studying for the test. This makes sense? Ultimately, what this means is that this little economy we've set up is essentially a game theory problem where you have firms and workers each of whom's decision is shaped by the decision of the other player. Right? So firms can decide, do I hire test passers or not hire test passers? Right? They can decide their hiring policy. Meanwhile, firms can decide, workers can decide, do I get qualified or not. And essentially what we've just worked out is the payoffs in each of these 4 possible situations. So if firms decide to hire test passers and workers decide to get qualified, firms are going to earn $100,000 for each worker that they hire, right? They're going to hire everyone as an engineer, pay them $100,000, get $200,000 back. Meanwhile, workers are going to earn $80,000. Right? On the other hand, if firms don't hire test passers, workers still get qualified like chumps. Workers are only going to get $20,000, right? The $40,000 from being laborers minus the $20,000 from studying, and firms are going to end up at 0, right? They're going to hire everyone as laborers. They're not going to make any money. If workers don't get qualified and firms hire test passers, then workers are going to get $60,000. Right? They might get lucky and get the $100,000 job without having to actually study, whereas firms are going to get negative $100,000. Right? They're going to hire workers who aren't actually qualified for the job. They're going to lose money as a result. And then finally, if workers don't get qualified and firms don't hire test passers, workers are going to get $40,000. Firms are going to get 0. So as a result of this, basically what we just worked out is that there's 2 possible equilibria, right? If the firms know that the workers are all qualified, they're going to want to hire test passers. If they know the workers aren't qualified, they're not going to hire test passers, right? Because 0 is better than losing $100,000. Likewise, if workers know that firms are going to hire test passers, they're going to get qualified. If workers know that firms aren't going to hire test passers, they're going to not get qualified, right? So there's 2 different stable outcomes in this economy, one of which is better for everyone, one of which is worse for everyone. How could we actually solve this problem? Well, one thing to note is that we're solving a super simplified version of this, where you either do pass the test or you don't pass the test. We could have, in the original Cote and Lowry model, right, we've got a whole range of test scores. You could get anywhere from a 0 to 100% on the test. And their conclusion, instead of it being 0 black workers get qualified, 0 black workers are hired, it's that a lower percentage of black workers are hired, and that the qualification thresholds are higher for black workers than white workers, right? So if you're superlative and amazing, you can still get hired as a black worker, but you don't have to be you can be mediocre and still get hired as a white worker, right? So they offer a couple of different potential solutions to this problem. The first one is affirmative action. What that means in this world is that we say, you need to hire the same fraction of black candidates as white candidates, right? You need to have diversity among your engineers. What's the consequence of that policy? Well, the consequence of that policy is, if firms have to hire some black workers, they're going to start hiring the black workers who pass the test, right? Now, if they start hiring black workers who pass the test, in the first generation, because black workers made their decisions about investing in skills, not expecting to be treated fairly by the hiring process, right? Not expecting to be rewarded for their skills, the new black workers who are hired under this policy are going to be less likely to be qualified than the white workers that were hired, right? In the first generation, affirmative action is going to make firms less productive. However, in the next generation, the consequence of this policy is going to be that black workers will expect to be rewarded in the same way for acquiring skills as white workers are. So instead of being in 2 separate equilibrium, right, one where black workers don't expect to get rewarded for skill and so don't find it valuable to invest in skills, where white workers do, we'll end up with everyone making the same decisions about investment skills. So if the policy is sustained for long enough to break us out of this equilibrium and move to that equilibrium, the consequence of affirmative action will be to permanently solve this problem, right? To break us into a new equilibrium where differences between black and white workers disappear, and firms who try to maintain different standards for black workers and for white workers end up suffering a bigot tax, right? Because they're, as an individual firm, their decision to discriminate won't be backed up by essentially systemic oppression across the entire workforce. Okay, One last thing I want to end with before we get together on Zoom to talk about this more. It's the ways in which this is and is not different from the models explored by Becker, right, in its implications. So as we've talked about, right, the big difference in implications between this and Becker's model is that Becker sees at some level discrimination as a problem that can be solved with market competition, right? We just need to make the market more intense. We need to have pressure on firms to become profitably larger, and that's going to override these prejudices that emerge from somewhere outside of market forces. Coate and Lowry disagree. Coate and Lowry's model argues that intense competitive pressure, market forces, if anything, just sustain discriminatory equilibria of this type, right? Situations where discrimination on the part of firms changes the behavior of employees in a way that rationalizes the discrimination on the part of firms. In a model like this, the only way to escape the discriminatory equilibrium is with some sort of concerted collective action, right, aimed at addressing the effects of racism. Whether that means, equal opportunity policies, affirmative action in hiring, whether that means lowering the cost of education for marginalized people and marginalized communities, whether that means, collective intentional efforts to be anti-racist, right? Actions on the part of white employees who are receiving favorable treatment to demand equal access to jobs and opportunities on the part of marginalized employees, right? It's not going to be a problem that's solved by individuals acting in their own best interest. It's a problem that's going to be solved by people collectively acting to address this problem. So that's the way in which this is significantly different from Becker. The way in which this is similar to Becker is that in the Coate and Lowry model, discrimination is, from the perspective of economic growth or output, kind of a tragedy, right? Nobody wins from this equilibrium. Employers are worse off and employees are worse off than if we were in an equilibrium where everyone was rewarded fairly for their work. And this is something that we've got some decent evidence for in the real world. There's this paper I really love by Cheng-Tai Sui and Eric Hurst and a couple of other authors called The Allocation of Talent in U.S. Economic Growth that essentially estimates, using macro forecasting models, which we don't need to talk about, estimates that something like 20 to 40% of U.S. GDP growth from 1960 to 2010 can be accounted for by basically allowing women and ethnic minorities to enter skilled professions in the United States. So, for example, 94% of doctors were white men in 1960, and something like 62% of doctors were white men in 2010, right? So still overrepresented, but significant increase in representation of women and ethnic minorities in these high-skilled professions, right? They basically say, if not for that integration, if not for that inclusion of more people into the top of the economy, we would have had substantially less growth over the second half of the 20th century than we actually did, right? A period of unusually high growth in the United States. So in this sense, right, discrimination in these models is something that hurts everyone, and the problem is that it's challenging for any individual to solve, right? It's a collective action problem that needs to be addressed collectively. In a number of other conceptions of discrimination, including conceptions born out of stratification economics, including a wonderful paper by Kaushik Basu, both of which we're going to talk about next time, this isn't quite true either. In these conceptions, discrimination might have real benefits for the advantaged group, right? Real benefits for whites in the case of racial discrimination, real benefits for men in the case of gender discrimination. In many ways, that doesn't change a lot of this calculus, but it does change our thinking about who would or would not support collective actions to redress or change discrimination. Okay, I'm going to stop there. Really looking forward to talking to you about all of this on Zoom, and I'll talk to you soon.